Welcome to Ask and Learn.
So we know the domain for this one is x is all real. And for intercepts, 0, 1. There is no symmetry and there's no asymptotes. Let's find the first derivative. So y prime equals 1 minus sine x. So if we set the first derivative equal to 0, we can find critical points at every pi over 2 plus 2 pi n. So if you make a plot for f prime, this is our first derivative test, so this is pi over 2. So we're just going to do one period. So positive, positive. All right. So it's not a min or a max. We're going to see an inflection here. And now I'm going to solve for the second derivative. So y double prime equals negative cosine of x. And if we set that equal to 0, we see x at every pi over 2 plus pi n. And if we draw the line for this, f double prime, if this is pi over 2, and this is 3 pi over 2, negative, positive, negative. So over here it's going to be concave down, here it's going to be concave up, here it's going to be concave down. So let's try to graph it. Actually, let's, since we're just going to do one period, let's make it all primarily positive. All right, so over here we have pi. Over here we have 2 pi. So that means here is 3 pi over 2, and here is pi over 2. All right, and we said that we have an intercept at 0, 1. So let's say this is 1. This is our intercept with the y-axis. Next, we see that there is a switch from concave down to concave up at pi over 2. So this is pi over 2. So it started concave down, and then the second it got to pi over 2, it's switched concave up, and it's going to keep going concave up until about 3 pi over 2, then it's going to go back. Pi over 2, and now it's going to start to go back to concave down until we get to the next pi over 2 plus 2n, where it will then, but for the period that we have, it's right here. So from here to here, this is one period.